king of vectors.
Write the ordered triple that represents the vectors. Alright, to write the ordered triple for XYZ pairs, you use this equation. Plug in the numbers from the two pairs into the equation, and that's your answer. To find the magnitude of an ordered triple, first you square x, y, and z. Next you add them together, and then finally square root the answer. Some problems will ask you to find an ordered triple by adding or subtracting two XYZ pairs. You simply use the numbers given and plug it in for the variables. So first, do 3 times p plus negative 2 times q by distributing, and then add after to get your final answer. Now let's take that answer and learn how to write it as a sum of unit vectors. The ijk corresponds to the xyz pair respectively. Now I'll do another example. Now there are things called XYZ graphs. The diagonal axis is the x-axis and the positive side is flipped with the negative side. The y-axis is the horizontal one and the z-axis is the vertical one. For an example, let's find the point -3, -1, 1. Now since the x-axis is flipped, we would go +3 instead of -3. Then left one space on the y-axis, and then up 2 spaces on the z-axis, or 1 space. And that is your final point. You can erase the other points.
Find the initial horizontal and vertical velocity of a stone kicked with an initial velocity of 16 feet per second at an angle of 38 degrees. So you have to find the initial horizontal and vertical velocity when only given the angle and initial velocity. First, set up your problem with the diagram and label your axes, initial velocity, and angle. Then, use these two equations to find the velocities and plug in the information given. £50 of vertical force on a rope lifts an object 30 feet. Find the work. Work is equal to the force of an object multiplied by the distance traveled by the object, and the units for work are usually in foot-pounds.
So, here's how you find the cross product. If vector A equals A1, A2, A3, and vector B equals B1, B2, B3, then vector A cross product vector B will equal the determinant of this matrices. Here's an example of the cross product. If vector V equals 0, 3, 1, and vector W equals 1, 2, 4, then find the cross product. So, cross product of vector V and vector W will equal 10i plus 1j plus 3k, which is the sum of unit vectors. And the ordered pair will be 10, 1, negative 3. The cross product is a vector perpendicular to the plane containing the two original vectors. In other words, the cross product is the way to find a vector that is perpendicular to both given vectors. The inner product. This is also known as the dot product. If vector A equals A1, A2, and vector B equals B1, B2, then the inner product is vector A times vector B, which will equal A1 times B1 plus A2 times B2. Two vectors are perpendicular if and only if the dot product is equal to 0. Okay, example 1 of the inner product. Find the inner product and state whether the two vectors are perpendicular. Vector P equals 7, 14, and vector Q equals 2, negative 1. So first of all, you have to find the dot product of P and Q. That will equal 7 times 2 plus 14 times negative 1. That will equal 14 minus 14, which indeed does equal 0. So, yes, the two vectors are perpendicular because the dot product is equal to 0. Here's an example of adding and subtracting vectors. So, problem number 1. Let vector m equal 5, negative 7, vector n equal 0, 4, and vector p equal negative 1, 3. Find the following vector m plus p. That will equal 5, negative 7 plus negative 1, 3. So that will be 5 minus 1, negative 7 plus 3. That will equal 4, negative 4. B. Vector m minus vector n. That will equal 5, 7 minus 0, 4. That will be 5 minus 0, 7 minus 4. And that will equal 5, negative 11. C. 7 times vector p. That will equal 7 times negative 1, negative 3. And that will equal negative 7, 21. And D. 2 vector m plus 3 vector n minus p minus vector p. That will equal 2 times 5, negative 7 plus 3 times 0, 4 minus negative 1, 3. That will equal 10, negative 14 plus 0, 12 minus negative 1, 3. That will then equal 0 plus 10 plus 1, negative 14 plus 12 minus 3. And finally the answer will be 11, negative 5.
Determining magnitude and direction of vectors. A vector is a quantity that has magnitude and direction. Magnitude is the length of the line, and direction is the directed angle between the positive x-axis and the vector. Standard position is the initial point at the origin, 0, 0. Next is finding the sum of two vectors and drawing the resultant. A resultant is the sum of two or more vectors. One method of finding the sum of two vectors is called the triangle method. The first step is draw the vectors so the terminal point and initial point are on the same point. Second step is draw the resultant from initial point on first vector to the terminal point on the last vector. This is the example of drawing the sum of two vectors. On the top left, you see an angle That's 40 degrees and 5.5 inches long. That will be vector B. And on the bottom left, you see an angle that's 25 degrees and 4 inches long. That will be vector A. So first you draw a point from the bottom. That will be vector A, 25 degrees and 4 inches long. And then from the end point of vector A, you draw vector B. That will be 40 degrees and 5.5 inches long. The resulting point will be vector A plus vector B. Writing the ordered pair of vectors. The initial point is P1, x1, y1. The terminal point is P2, x2, y2. An ordered pair that represents P1, P2 is x2 minus x1, y2 minus y1. Magnitude is absolute value of P1, P2, which is square root of x2 minus x1 squared plus y2 minus y1 squared. This example has two givens. The first one is P1, which is x7, 3, and the second given is P2, which is y2, negative 4. You have to find the vector P1, P2. You find this by subtracting x2 by x1 and y2 by y1. How you do that is 2 minus 7 and negative 4 minus 3. That simplifies out to be negative 5, negative 7. P1, P2 equals square root of 2 minus 7 squared plus negative 4 minus 3 squared, which simplifies to square root of negative 5 squared plus negative 7 squared. That equals square root of 25 plus 49, which simplifies to be square root of 64, which is 8.